with the release of 3.0, some of you are not upgraded yet. I highly recommend you do so. I decided to build a pack. Packs are like add-ons that you would install from a Splunk base, but this is in our version of that that's in Git. So I'm going to share my screen. But before I do that, I'm going to do today's featured guest along with myself. We have Brendan Dalpe, who is a solutions engineer genius extraordinaire, and John Rust. You guys go ahead and introduce yourselves.
Hey, thanks for the intro, David. Brendan Dalpe, one of the solutions engineers on the Cribl team. I'm based out of Kansas City. Happy to show some of the cool stuff that we've added to the Knowledge Pack. Some interesting things here.
Perfect. John?
John Rust, been with Cribl almost 3 months now. Solutions engineer also in Camarillo, California, just north of LA. And yeah, can't wait to see some of these cool functions and tricks.
So for those of you that didn't know this that you see on your screen, I think everybody can see my screen, correct?
Yeah, we can.
All right. Yes. This is the Cribl Pack dispensary. You can see this, github.com/CriblPacks. And today we're going to be talking about the Cribl Knowledge Pack. And feel free to follow along and explore if you get bored, but I'm going to walk you through something that you might not know because it's kind of hidden, but we're going to update this soon. Inside any given pack, you can see that we've uploaded a pack, and there's the README files and things like that. But in order to easily install a pack, over to the right side of the screen, simply click the release. You're going to download the .crbl file, which is nothing more than a tar gzip file. And then you can go to Logstream, add new, and import the pack from a file, just like that. Wanted to make sure everybody saw that. That's as simple as that. You can see here on my screen, I'll make it a little bigger. I have a lot of packs. One of them is this brand new Cribl Knowledge Pack. And the Cribl Knowledge Pack is kind of the painful experiences when many people of the community have reached out and said, how do you do X, Y, or Z? Brendan, John, myself, we've kind of built this so that it's easy to follow along. The idea is this. We start out in the Cribl Knowledge Pack in the routes. I've matched up the same name so that you can know which pipeline it affects. And I've also named the sample data the same thing. So we're going to start at the top of time and work our way down. So I'm going to jump into the time.
David, before we jump into this, can you talk about how you get data into a pack?
Yes, absolutely. So in this example, I'm in packs and I'm already in the knowledge pack. You can see over here on the right, it says pack only or all, which would show me every single sample. There's many ways to get data into a pack. You can click paste. And don't be distracted by the middle box here where you click it and then you have to upload, because if you want to paste, you can just click over here and paste. You can upload a sample file right here. You can attach, which is the same thing, or you can do a capture of live data that might be streaming in from any given source in your environment. And that's how I add data to packs. Anything to add to that, Brendan?
Yeah, how about from the main routes and pipelines? How would I get the data shuffled over here so I can process it?
Go ahead, tell us. Let's hear. I can't read your mind.
So go to the routes tab at the top there, at the top menu. There you go. So in your route listing here, if you select one of the route entries, you'll notice some of these pipelines and outputs have the little pack tag next to it. So if you were to build a route in here, if you want to just expand that first route on the left for me, please. Notice that the pipeline has the pack tag also. So in your dropdown, you'll notice, in addition to the pipelines that you've built, inside your worker group, you'll also have the packs that are imported into your worker group. So you can choose the pack that you want, or you can choose a pipeline, whatever makes sense. So that
I think it's important,
yeah.
To add to that is that the route filter is the first thing that, matches on that data set, where then it enters this pack. And the way it was described to me when we first put packs out there was when you enter a pack, you're kind of entering a mini log stream that doesn't yet have sources and destinations available, but that's coming soon. But as you can see, when you enter a pack through a route filter, you land in the pack and you can see that there's additional filtering that can be done so that you can apply different pipelines in the pack based on the filter set that you see here in the pack. Once it enters the pipeline and finishes processing, it will leave the pack and go back out to the original route where it gets finished processing and then sends on to its merry way to the output or output router destination. So feel free, if you have any questions, by the way, to chat, chime in, ask live, interrupt us, because that's what this is for. This is your session for you guys.
Hey, David, is there any noticeable impact running through a pack?
No, there'd be no noticeable impact. It's pretty much just the similar experience, but we made it a little easier. The reason why it's so great for someone like me is instead of, let's say I wanted to share a pipeline with you that also used a lookup table, well, I would have to, in the before packs, I had to export the lookup table, export the pipeline, and then you had to first import or create a lookup table, then import the pipeline. And this saves all of that time. And it also really opens this up because the same experiences, once you get used to building your own packs, means that you can upload your pack to your own repository, share that pack with our Cribl community, and then other people can use Git to check out branches and fork the repo and update things, check things in and request a PR where we can review the contributions from our community so that it's going to overall improve the packs each time somebody decides to request some new enhancement or change. So it really lends itself a little bit better to our community to add enhancements, updates, and give us feedback on these packs.
The other comment that I'll make on that, David, is the ability to export the packs inside your system to the other worker groups themselves. So let's say you have a standard set of templates that you apply across a wide variety of data sources. You have many different worker groups. Not only can you export to a CRBL file, but you can export to a worker group as a target and choose which one. So David, in this situation, is going to export this pack over to the worker group that I have inside our lab. So it's a great way to be able to build it once and export out to many different worker groups. I think that may already exist in my worker group. So there you go. You can see that in action there.
Okay, so let's review where we're at, which is the Cribl Knowledge Pack. Imagine that, again, this is more of a learning pack, not so much some type of real-time processing pack. The idea is that one pack to rule them all as far as knowledge goes. Every time we come into unique use cases, we're going to add more sample data, more pipelines to give you, extra capabilities so you can enhance your knowledge with our product. So we're going to start with this first route filter pipeline. And you can see we did this on purpose, by the way, showing many different ways that you can approach the filter of a specific route. This is just a Boolean test of a yes or no, does it match? You can see a raw dot match, which isn't as performant as a test. You can see starts with, you can see includes, you can see even if a field exists or just true for everything. So over to the right, you see under the pipeline column, we have time. I'm going to go into this pipeline. And I wrote this pipeline, and every comment will look exactly the same here. You're going to see a summary, the author, the date, the sample, which sample to use, and other information about, that might be, usable by you, like references and links and things like that. So I'm going to jump into the time sample over here on the right. And it just, this exact works with pretty much any sample because I'm using current time. But we're going to explore time because a customer said, I can't do strip time. It's not working. So what I did is I put together one eval that demonstrated to him why it wasn't working. And let's explain this quickly because we have plenty to go through. So he had a time that strip time wasn't working. So what I did here is set two time variables here. And I used a new date and then new date to ISO string. Over to the right, you can see the ASCII strings are identical, A time 1 and A time 2. But if you were to do a test, are they equal, basically? You can see I did it with type and value. They're not equal, but it's confusing because when you look at your screen here, it looks equal to me. So I decided let's run some additional testing. We'll convert both. You can see A time 1, is it equal to it if it's set to ISO string? And now they are equal. Well, that got me thinking about why. So what I went ahead and did is first I used stringify, because we do that. Sometimes we want to see JSON as a string. Again, they still look the same. It was only when I ran string against A time 1 and A time 2 that I could see right here, that these two fields are not in fact equal. The values are very different. So I wanted to understand that a little more. And so, of course, I asked our engineering team, and Brendan has reviewed this with me as well. And ultimately, the point of it is, as you go through this function, you'll see that I'm using various functions like instance of date right here. And you can see one of them is an object, a date object as a type, and the other one is a string. But when we use JavaScript to present them, they displayed the same because that's what JavaScript can do sometimes. So ultimately, what I learned was that I needed to use to ISO string for my strip time to work properly. And this time pipeline, this function, just gives you many different examples of how to use that. Can somebody mute the music person, whoever that might be? Thank you. Okay, so that is a quick review of the time function. Again, there's a lot to go through today, and we're available on our community Slack to talk through anything that you might have a question about. Now we're going to jump into the next pipeline.
Before we leave, at Rachel's encouragement, can I jump in and ask a question?
Please.
When you're looking at the sample just there.
Yes.
To the left of the fields, once you run it, are the little symbols, looks like an alpha, a number sign, a B. Is that supposed to give us hints to the type of field it is?
Good question. Yes, and that's why actually I should have said that in the beginning is, yeah, you can see here, numerics, ASCII string, Boolean, true or false, and JSON string right here. And I felt the same way, and I had actually put in a JIRA ticket saying, you know what, since I didn't know this, can we add like a letter D or something? And we're actually annotating that in our docs to say, be aware of this, and we're making decisions on what to do about that because it is kind of more of a JavaScript behavior than anything else. And so we're not sure if we're going to just say, yeah, be aware that's the letter D, because that might confuse people in a different way. Good question, though. Thank you.
Perfect. Thank you.
All right, let's jump back to the routes. We're going to go into function number 2. That's going to demonstrate a lot of things: regex, mask, serialize, parser, and eval. We're going to jump in here, and we're going to go into the sample. And this one was very interesting because the customer said, how can I parse events that have spaces like group name, device name? I'm using these very specifically. And if anybody wants to volunteer, what you think would happen if I turn all these off and used a key value parser function to parse these key values from this raw event? Anybody care to guess what's going to happen?
Lots of name.
One would think that as well. So if we turn this on and we hit save, let's hope it works. Let's see. Do I have anything else left on here? I don't believe I do. Parser, extract raw. Oh, actually, what I meant to say is extract raw. There we go. Let's erase that. Okay. Do you see just one name here? So that's also a behavior of JavaScript, is when you're using parser, or pretty much anything, Grok, a lot of JavaScript things, it's just going to pick the last one that it found. And that's the one it preserved. It didn't like create an array for you. And so be aware. And also you lost the word before this. You lost group name and device name, and you ended up with just name. That can be scary. And I can get now, a lot of you are probably panicking, thinking, oh, I need to now go back and look at my functions. So I did that on purpose, leave it off because it misses fields with spaces and you lose some of your values. So let's turn on the next one, which is, let's break this into steps. And normally when I extract my fields, so I don't have to use an eval to remove them, I will use double underscores here because we don't let them leave logstream. I didn't do that for the purpose of education here. We're going to turn on this regex, and you're going to see that I created a regex to break off the first chunk of this event so that I can pretty much deal with a simpler regex right here. I kind of do that a lot. Sometimes people try to over-engineer a regex, and it's a lot of work to try to do that in one regex, and sometimes it just doesn't work. So the next regex is something that, if you're familiar with Splunk and the Splunk docs of transforms.conf, they've always supported the idea of key underscore number, value underscore number. And we do the same. So this regex, when I turn this on, will go against the step one source field, and it will extract properly all of the field names with, you'll notice here, the space is being replaced. So one of the things that people may not have noticed about the regex extract function is that we have the ability to format, after you've regexed the right key out, I basically said, you know what, for that key name, let's replace all spaces globally, didn't really need the G, with an underscore. Actually, I did need that in case there's like multiple spaces in a field name. So that's just one approach. I simplified this because Brendan remembers when I originally did this, we put in a whole ASCII character set in there with a bunch of other things, but I figured it would be good for presentation. Once we do that, and again, this is all about examples. There's key values, and this comes up a lot, which is I'm going to put it into key values because that's going to give me the smallest event, 47% reduction. Does anybody think that JSON extraction will be smaller than key value extraction? Feel free to chime in. All right, let's show you. So we're going to turn on serialize and parse. If I could turn on the group, there we go. And we're going to hit save here. So what do we see here? Do I have everything off the right way? Serialize, parse. Oh, let me turn off the, let's see. Do I have everything right? Yes, I do. Okay. So we can see this is a JSON string, and the size, we didn't get as much reduction out of there. But again, I have this set up in such a way that it says leave this off if 10 is enabled, because we have now a nice JSON string. If I turn this on, what this is going to do is stringify raw. Because why is it a lot bigger? Because there's a lot of escaping going on in the JSON string here, and those take up room. So if I were to turn this off, and remember, this is an ASCII string. If I want to turn this into an object literal, which basically means it's no longer an ASCII string, and this is done with, and you can do this with the parser command, you can do this with an eval command, and we have different examples for that as well. When I save this, you can see the string is now an object literal. It's still got the same data, but we have actually saved even more room by pushing this into an object literal, which Splunk readily accepts. And I've actually made, and you know, up till recently, I think most people have always said to me, key value is smaller than JSON. Well, hopefully I've shown you that there are ways to even enhance that a little bit. The last thing is just cleaning up, you know, getting rid of or choosing to keep whichever common information model type fields you might need, tstats, extracted fields, whatever they want to call them these days. And that's an example of this pipeline. Are there any questions? All right, Brendan, it's your turn. Do you want to request access to my keyboard so I can give you control? Or is this me? This is me, isn't it? Oh,
I just sent you a request.
okay. Well, this function was me, but you know what? I'll let you click it. You take control.
Cool. Yeah, so let's take a look at the base 64 decode here. So inside this pipeline, we're going to use the mask function and one of the internal functions, c.decode. So if you don't know, we actually have a fairly comprehensive list of internal functions, and you can find those on our docs site, docs.cribl.io, under the Cribl functions. So c.decode is what we use here. And let's pick our base 64 decode sample. So in this situation, a customer came to us and said, hey, I've got some PowerShell that I've captured as part of my Windows system logs. And you can see this PowerShell here is an encoded command, base 64 encoded. So we want to obtain the original plain text of this encoded command before we send it out to the system. So what we're going to do here is a couple different things. First is we're actually going to use the mask function to highlight the ability to change this in line. Honestly, the mask function to me is one of the most underrated functions in our tool set here. So I'm going to enable this. We've done this a couple ways. This first option one with the mask is using what's called positive look ahead. So in regular expressions, we can use a look ahead and a look behind to position where we want to capture this data and validate if the look ahead is captured, or if the string inside the look ahead exists ahead of what we're trying to capture, then it's a valid match. We can also use a look behind to say, if the data behind, does this match? If so, then we have a positive match there. So in this case, let's take this example here. So we've got our encoded command. What we've done with our regular expression here is we've used this look ahead. And this look ahead is what I'm highlighting here, this question equal encoded command. So what I want to do is say, if this exists, basically match up to this section. We don't know where this encoded command flag is going to exist inside this process command line. So we want to match up to this. So now that we've matched this up to, we can extract out the capture groups, and you can see the replacement expression here. We're going to process this process command line, and we're going to use the decode function. And one of those sub-functions inside decode is base 64. So we have a couple different capture groups here. You can see in the match info here.
What's that UTF-16LE?
Yeah, I'm getting there, David. So within our capture groups, we have our first, our second, and our third. We've got that referenced here, G1, G2, and G3. Yeah, settle down there, Sparky. Thanks, Rachel. So basically what we're going to do is this third capture group, G3, when Windows forwards this data is actually encoded in what's called UTF-16 little endian. And that's the specific format that's used. Usually it's ASCII or UTF-8, but Microsoft has to be different and do their own thing. So we have the ability within the decode function to use the specific encoding that Microsoft is using. So all of those are, what encodings are available. Those are on the docs too. So if you run into a specific case where you can't decode it for some reason, try a different encoding. It might be something that you're not expecting. So yeah, let's try this UTF-8 for some reason. You can see here, did it actually update?
I don't see it. No. Huh. Well, I think it's okay or something, probably, I'm guessing, because it didn't save it or something. I expected the different outcome as well.
Yeah, that's fine. So let's actually do this. Let's just take this out because we don't need it.
Say okay.
Huh.
Yeah, that screen should update live. I don't think
should.
we need to. Okay, yeah.
It's wild. Okay.
That's fun. Well, that should be doing what we think it should be doing, but
maybe the sample data just doesn't need it.
Anyway, so we've got our option 1 here, positive look ahead. So we've done that inside the function. We've got our second option here, using 2 capture groups. So in this case, this function is using a slightly different version of our regular expressions. We are matching everything up to the encoded command and then capturing everything after that. So grabbing the encoded command here. So in this case, you can see we've matched this. I'm going to try this again now that I've enabled this function. So do we get an update on that?
Hey, did you can you highlight that again below the output?
Yep.
Okay. Yeah. Weird.
Yeah. So,
Okay.
Anyway, let's click OK. See if that changes our sample data. No, still good. Okay.
It was something maybe, I don't know, that we did actually see in the product that it was exposing null characters in the when it decoded it with the wrong encoding specified. So I don't know why it's not working here.
Yeah. So interesting. And then we have a slightly different example here using a negative look behind. And this is the question left caret and the equal sign. So look behind this to find the encoded command and then find the text after that. So you can see we've actually only have 1 capture group in this situation here for this because we want to find our string with this behind it. This does not get included as part of the capture group. Look behinds and look aheads are never captured in ECMA script, which is what we're using here.
Also, the most underutilized pieces of regex that I always love to use. And I think people get scared off by the terms of look ahead, look behind, positive and negative. And if you can learn those and master those, I think it's going to help your regexing tremendously. Is it not clicking?
Cool. Yeah, I'm clicking cancel. It's not. There we go. All right. Any questions on our base64 decoding pipeline here? It's a pretty cool one with the mask function, I think.
All right, so this one's going to speak to where we are now and where we're going with packs. This next one is the regex lookup, unroll, and router. For those that are unfamiliar, we're going to talk about what unroll is doing. So I'm going to jump into this pipeline, go into this sample, and a very simple sample, just 4 host names, maybe, well, multiple host names with different things. Some of them have a number, 1 through whatever. Some of them have a country name in them, and some have a specific function in them. And so the idea was, first, let's just turn this off and step you through this. Let's just extract the host out first. So we see host. That's a simple regex like that. Then we're going to go against a lookup table. And let's talk through this lookup table just a little bit here. Because in the Splunk world, people are used to kind of an exact match or maybe a simple wildcard for a lookup. And what you can see here is you can insert the regex as entries in the lookup table. So what I hear said, if I find any of these words, the pipe is the or. If I find this specific word, then destination is going to be Datadog, but everything is going to be set to S3. And I'm matching on this host. So let's go back and take a look. So I am saying use a match mode of regex and return all values because it could match more than 1 entry. And so when it does that, I'll turn this on here, hit save, you're going to see it's going to return an array. Splunk does not love arrays. In fact, it'll probably ignore this. So we have a piece in our destination of Splunk that can flatten things automatically. That's part of the destination behavior. You can find it there. But I'm going to use this. So clearly, you kind of know where I'm going with this is if I have this destination, go to Splunk, and this other tag, go to S3. How can I handle this array? Well, I'll use the unroll. Unroll lets me pick an array, specify the source and where it lands in the destination, and it's going to explode this one event into 2. This one event, since there's 3 entries, into 3. Let's turn this on and watch the magic. So now you can see destination Splunk. It's now flattened. It's just key value. Destination S3. The same event is now cloned. Same thing down here. Now imagine perhaps you wanted to say, oh, now that I have individual events with this tag, maybe I change the source type because Splunk needs a source type. and I add a source type to events that have this destination of Splunk, but you can see below that these events don't have source types unless they are, again, intended to go to Splunk. And maybe you do some final behaviors, serialize things back to raw as a JSON object, or in this case, I should say a JSON string. I should update that. But the last piece is output routers that I just think the world of and not enough people know about. I could shout it from the rooftops. So I'm going to go to destinations here. And this is when I say coming soon in a pack near you. Packs do not support sources destinations yet. That's coming in the future. But we're going to open up destinations, and we're going to go to this underutilized output router. So the output router lets me specify JavaScript expression so that based on whatever I've set, and this is just a simple filter, destination is equal to Splunk, go to Splunk. But I could say finalize. Clearly, nothing's going to be done there. Let me click this again. As far as the event will not traverse any more output destinations. But if I turn this off, then it's going to continue down this path. Destination equals Splunk will not match this next filter expression, but anything that says destination equals Elastic will go to Elk. But true means, of course, either one of these has any one of these values, all values in this sense, is going to go to S3. So with one simple output router, I can send the data to any number of destinations that I want based on these really powerful filter expressions here that we use as rules here. Anything to add to that, guys?
Yeah, I'll comment on this too. And Eugene just made this comment in the chat. Output routers are very awesome for, let's say you have a multi-site Splunk indexing cluster across, I'll just use AWS as an example, 3 different availability zones. You could use an output router as a destination. And the little trick here is you can actually use an environment variable set inside the log stream systemd file, or however you're running log stream. And what your filter can do is check to see the environment variable. What is the site of this worker? If it's in site 1, we want to send it to Splunk indexer site 1. If it's site 2, then we send it to site 2, or site 3, send it to site 3. So this cuts down on things like cross availability zone traffic, which Amazon charges you a nominal fee for, but that can add up over time. So I say this is a good way to make your log stream workers site aware. So it's an interesting way of doing that.
Yeah, that's pretty much exactly what we're doing with the output routers.
Fantastic. All right, so we're going to speed it up a little bit because I'm watching the clock and I know that we have a lot to cover. So, again, we've documented every single one of these quite extensively. So I think what I would like to have happen now before we run out of time is I'd like John specifically to speak to this specific route function here, because I thought what he did was super clever with Cisco logs. So John, you have the helm.
So with the, where'd it go?
Regex variables from lookups, that's yours.
There you go, you renamed it. Okay. So with this pack, what we've got here, let's pop into our lookup file first. Let's start with the pipeline. So what we're going to do, we've got ASA files coming in. The sample file,
it's up 4.
There you go. Thank you. So sample files are pretty standard syslog files coming from ASA Cisco gear. And what we want to do is 2 things. We want to drop for codes that we don't want. And actually 3 things. We're going to clean it up a little bit. We're going to drop for codes we don't want. And then based on those codes, we want to have regex that pulls out the information we need. So how do we, without maintaining a ginormous list of rules in here with thousands of different regex, how do we manage that? So the first thing we do, I've got this well commented, I'll leave the comments out. We're going to use option 1. I've got 3 different ways of doing this. Option 1 is the most clear. We're using the built-in functions one at a time. So the first thing we do is a simple regex extract to grab the ASA code. Very straightforward. We can see, I'll I'll just keep going through here, make it quick. Based on that ASA code, we're going to reference the ASA drops lookup file. And if that ASA code matches, I'm going to pop over to the knowledge.
That's pretty cool. So
area.
you put a lookup in your filter. I don't know if everybody knows that you can do that.
Yeah, so using, good point, David, thank you. Using those C functions that Brendan mentioned earlier, we've got a lookup function that you can reference, and it'll just turn true or false with this simple way of using it here. So we're looking up the ASA code, and based on whether or not that code exists in the drops, let's see, and you can see it's just a list of codes, and I've included a comment column here. That's optional, just so you can keep track of why we're dropping those specific codes. So if that code exists, we're going to drop the log. The next thing we're doing is we're going to mask. Using the mask function, we're just going to lop off the front of this code, the front of the log, up to the ASA code. We've already got the time extracted. That's part of the, as the event is initially brought into the system, we've got the time. We don't need it in the raw event anymore. So we'll drop that to save some space. And then this is where we get a little tricky. David mentioned, you can use your lookup based on regex. And I was wondering when I was putting this together, can we use a regex as a result of a lookup? So if we pop into the regex or the ASA parsing lookup file, see, again, we've got an ASA code, but what we're actually getting back is a regex with groups inside of it, defined inside of it. So for each, and there's thousands of different ASA codes. I'm working on a pack that has about 100 of them defined. For each code, you'll have a custom regex pattern to pull out your groups.
That was an aha moment for me. I actually didn't even know we could do that until you showed that to me. And I've been here a lot longer, and I was like, that is the most clever, cool thing yet that I've seen in quite a while. So very cool.
Oh, thank you. Broken clock is right twice a day, right? So we've got, we're looking at the ASA code. ASA code is the name of the field inside the file, and we're returning regex. We're going to put it into a local double underscore field because we don't want to send that out after. And then we apply that regex. So using an eval statement, if the regex field exists, we're going to match and we're going to return the groups. So the groups comes back as an array of the matches. And further on down, we flatten those groups. So we take the groups array and flatten it, and then we're going to rename it to clean it up with the simple expression to remove groups underscore from the start of it. And if we do that, if we look at the results, so we've got fields dropped, and we've got these matches that came from the regex that was in. So if we show hidden fields here, we can see the regex was looking for ASA proto, ASA from IP, and ASA to IP. And those are now included at the top level of the event as an index time field. So that's the basic gist of it. To take it a step further, we wanted to show it 3 different ways. So we're using built-in functions here. The second option would be to use all evals. So eval is very powerful. All these things we can do with an eval. So the regex extract we can do with an eval using the match function. Drop, we still need to, the drop command is still the same. The cleanup, we can do the mask with a replace function on the string. And the lookup, we can actually do the lookup. It gets a little more complex than the simple case. But again, we can specify, we're looking at the ASA parsing file. We're looking for ASA code. We're going to match with the value ASA, and we're going to return the regex. And then we do the application of the regex exactly the same as before. And the results will be exactly the same. So no change to the right there. And then the last one, yeah, go ahead.
Are there any questions before we're just trying to be respectful of the time. We got about 14 minutes left. So
the last one, we can take all those eval steps and do them in one shot. So we grab the ASA value, we get the lookup result, we're going to use the lookup result to either drop it or not by flagging lookup result equal to drop it or the actual ASA code and other things. Then we're going to get the groups from the match. It's a fairly complex, moderately complex eval statement. You can walk through it without too much issue, probably. And then, if the lookup result is drop it, we're going to drop it at that point. And then all three of these result in the same, we have a groups array, and we're going to rename that group. So again, it came out with the same result on the right side. And, so the three different ways of doing it are just to demonstrate that the eval function is incredibly powerful. You can really, you can perform a lot with just the eval function, but also wanted to show the flipping the script on the lookup function, where we're not using a regex to match and lookup. We're using the regex return from lookup to actually apply and extract data. And hopefully that'll make your life easier managing, big long lists of potential matches.
Thank you very much, John. Great presentation of that really cool pipeline. I want to go through one that I thought was yesterday. Some people that are watching our Slack community saw a question come in where a person wanted to they had a nested object. And so there was a lot of conversation. I think the thread was like 60 items long of conversation between one of our developers, and then I jumped in, and we came up with, like you saw John do, several different approaches. One of them was super complex with a lot of object assign and using global variables. And then I came up with the idea of using a regex, but he said, well, I don't really like that approach because like your negative lookup can be very expensive. Regexes can be expensive for a lot of events. And he said, I can't use the negative look behind. So do you have any other approaches? And if I don't know specifically where this field, crypto group, whatever number is here in this object, that's also very difficult for me. So what I need to do is be able to take this information in the object and be able to hash it. And so I came up with an approach that he really thought was great. In fact, his comment was, I really over-engineered this. He had like 20 functions to do this. So in a nutshell, this is one way to do it. Again, you can use parser to do the same thing, extract raw from the source to the destination. I did this in an eval. So we end up, when I turn this off here and hit save, you're going to see we have an object literal and same event basically, but now I get to use mask. And what I specifically like about the powerful mask command is that in our docs, it references using wildcards, but I didn't know you could use more than one wildcard until the customer said, can I use 2 wildcards? I said, I don't know, I've never tried. So the idea was, go look for anything in this raw object and find where there's some crypto group underscore whatever number, and then mask all of the values, everything, using MD5 against the only capture group. So when I turn that on, you're going to see that the information here in ASCII, I'll hit save, is now masked, just like that. And I thought that was a really clever approach because I was all excited. I didn't even know that we could do 2 wildcards in the apply to fields. But again, sometimes I take the docs too literally. So that's a demonstration of that pipeline. Let's jump back over here. Brendan, you want to talk about the spread operator?
Sure.
Go ahead.
All right. Second. So this is a fun one. If those of you that understand JavaScript or know JavaScript well, this may not be a surprise to you, but for those of you that don't, this is actually a quite cool thing here. So when you call functions, you can give parameters to them. But what if I don't know the length of the number of parameters that I'm going to be passing in, or let's just say variable length parameters? In JavaScript, we have what's called a spread operator, and it's actually these 3 dots. So inside this event here, I just have an example. You can see we have a array field called response body bytes. And this actually represents a string. These are character codes, and we want to convert this into a string from these character codes. So what I can do is I can actually pass this to a built-in function, string.fromCharCode. But I need to pass in all of these as individual parameters. So I can use the spread operator to do that. And we'll take each of these and we'll pass them in. So our parameter 1 basically becomes 123, and then 34, and then 116. So basically what happens is on and on and on, we have this parameter set built in. So doing that with our spread operator, I'm going to cancel this. We can see here's now our output of that. We get an ASCII string representing a JSON object, which then we can parse and do whatever we want with this. So a very interesting thing that we received off the community is like, I'm sure there's a way we could do this. So if there's anything to mess around with, this is a fun one to take a look at.
Brendan, do you want to continue on with schema validation?
Sure. Yep. So schema validation is something that I don't think a lot of folks know exists in the product. So we have JSON schema validation built in. So what this allows you to do is in the knowledge objects, that's kind of buried away here, is, oops, I'm out of the pack now. That's not what I wanted to do. This is what I wanted. So just as a sample schema here, you can go online, json-schema.org, and read what this is exactly. This is a very simple example. This can be as complex as you need it to be. Checking to see, different sets of parameters, doing enumeration of values for fields. And in this case here, we're checking the minimum and maximum age for a specific field name. But basically what we want in the event, we're requiring a first name, a last name, and an age. So we want to validate across our events. Do these fields exist, and are they inside the parameters that we expect for this data? So what I'm going to do in the pipeline is actually validate against this. So I have a sample set here, schema validation. I've put myself in here. So within the parser function, we just extract out the ASCII string from the JSON here, and then we're going to use the Cribl internal function, c.schema. We reference the schema name, in this case, our sample schema, and then we have the validate function, and we want to apply that against raw. Now, just a note here, if I were to try to apply this without parsing this, you're going to notice the schema validation fails because we have to pass in an object to validate. If I pass an ASCII string, it's not going to work. It needs to be an object. So with that, we'll enable the parser. You'll see this will change here. So in this case, because I have passed in some valid values here, our schema validation returns true. In this case here, I've added Frodo Baggins, and his age is 50. So that fails validation because the age is above the maximum of 42. So this allows you to define, here are the different fields that are required, the different fields that can be expected, the values of those fields. And if they don't match, you could potentially send this off to a different system for remediation, or maybe an S3 bucket or something to replay later after you clean up failure of the schema. So many different things you could do with this here.
Thank you. Thank you very much for that, Brendan. So we have only a handful of minutes left. And again, feel free to download the pack from the GitHub Cribl packs. You can see the knowledge pack as well as plenty of others. John wrote this, the internal forwarder logs, being able to reduce those by like 90%. We have syslog preprocessing. Brendan put together the Palo Alto pack. Carly put together our middleware pack. This is the Windows XML and Windows Classic Events pack, and plenty of other packs that you see here. And we're going to continually add more packs here. So feel free to explore, learn, and give us feedback in our pack community. There's a pack Slack channel in our community, #packs. So look forward to your feedback. And so I'm going to pause. I'm going to stop sharing if that's okay, and open it up to for feedback and conversation. Anybody want to chime in, ask any questions? Feedback, please. And if not, we can end our session.
It's really cool. I'll be going back to the recording multiple times, and I'm sure, for the explanations.
Excellent. Well, thank you.
Thank you very much, everyone. That was awesome.
Is there any other comments in the chat we missed? Nope. I think we're all caught up on those as well. Yeah, output routers are amazing. And, I can't say this enough because I see this in the community Slack a lot, is why isn't my field rename working or whatever? That little nuanced JSON parse, or when Brendan showed that parser function to turn it into an object, that tends to be probably the number one thing that I see. It's like, oh, you forgot to turn it into an object before you tried to pull that field out. And they try to reference the field because it looks like the JSON string presents the same way as an object. You just can't do much with it. Like you can't get raw.objectName.fieldName.whatever from a JSON string. And it's only really good for regexing and things like that. So be aware of that. It can be a big gotcha. Okay. Well, Rachel, I think we're all done then. Thank you guys for your time.
All right. And it sounds like in 2 weeks, we're going to have a review of the next release with Nick Tank and Gayatri Pandiaram. Did I get that even remotely right? I apologize. Then we'll see you then.